Hi, I'm Lisa Hepp, and I'm an epidemiologist at the Institute for Global Tobacco Control at Johns Hopkins Bloomberg School of Public Health. Today's topic, we're going to be talking about one of the effective and easy ways of measuring the levels of secondhand smoke exposure through the use of hair samples. So in this presentation, I'm going to give you a brief overview of what exactly secondhand smoke is and how hair nicotine can be used as what we refer to as a biomarker in measuring secondhand smoke exposure. We're going to review the steps necessary to actually conduct a biomonitoring study, whether that's with hair nicotine or any of the other biomarkers. Some of those types of things that we'll be going over: the field materials, labeling procedures, the usage of data collection sheets, and the sample collection process itself. And through this entire process, we're going to be giving you an overview, an example of a protocol that actually steps through these different steps for sample collection. So at this point, you may be asking yourself, what exactly do we mean by secondhand smoke? So secondhand smoke is actually a combination of two types of cigarette smoke or cigar smoke, any type of burning tobacco smoke. The first type is called mainstream smoke. So mainstream smoke is actually what is exhaled by the smoker. They take in a deep puff of smoke and then it goes into their lungs, and then they exhale that smoke. The other part of secondhand smoke is known as side stream smoke, and that's actually the smoke that comes off of the cigarette or the cigar or the pipe itself. So it's a combination of mainstream and side stream smoke that makes up secondhand smoke. Secondhand smoke is very comparable to what the smoker is actually breathing in themselves as well. So it contains almost the same chemical makeup. They say approximately 4,000 known chemical components, the very same which cause all types of diseases and illnesses in adults and children. So exactly why would we want to monitor secondhand smoke? Generally, there are a handful of reasons why you'd want to do it, and one of the main reasons is here on the slide, is to actually document the extent to which a population or a group of individuals may be exposed to secondhand smoke. This in turn can help motivate the policy and actually give reason to monitoring compliance to ensure that laws that are in place are actually effective and that the secondhand smoke levels people might be exposed to are low and non-existent. And then the last point here, to actually monitor trends, which can be done through comparing buildings, different cities within a region, or even comparing countries if it's on a large enough scale. On this slide, we see a figure that is illustrating the causal pathway of secondhand smoke and how you can actually monitor it through different stages. So as you see, you can monitor secondhand smoke through air monitoring, through personal air monitoring, and through biomarkers. And it's this last part here, biomarkers, that we're going to be focusing on with today's topic. And as you can see, through the measurement of secondhand smoke and the use of biomarkers, you're actually being able to measure a dosage of secondhand smoke. So this dosage then is dependent on an individual's exposure, and an individual's exposure is actually dependent on the concentration. So all these things add up together and can give us the measurement of secondhand smoke in a biomarker such as hair or saliva. So we keep talking about biomarkers as a way to measure secondhand smoke, but what exactly, again, do we mean by biomarker? So a biomarker is actually an indicator that can be measured in a biological system, such as through saliva, blood, urine, or even hair. They provide indication of what a human or an individual's exposure is to various different toxins or other environmental sources. But today we're going to be focusing on biomarkers that can assist in determining exposure to secondhand smoke as related to tobacco smoke. Biomarkers of tobacco exposure have been used for many years to assess misclassification of smoking status, for example, in surveys and other epidemiological studies. And they've also been used to monitor and track population exposure to tobacco over time and in various places. A wide variety of biomarkers have been developed and used to measure the chemical makeup of tobacco smoke, and these include nicotine, cotinine, which is actually a derivative of nicotine, and other carcinogenic compounds such as tobacco-specific nitrosamines and polycyclic aromatic hydrocarbons. Other toxic chemicals such as carbon monoxide have also been used. So an ideal smoking biomarker would actually be specific to tobacco combustion, something that actually is derived from the tobacco itself. For instance, nicotine or cotinine, and even tobacco-specific nitrosamines. Another point that a great biomarker specific to tobacco smoking would naturally have a long biological half-life. And it would be an agent associated with or correlated with health effects. It's also important that the biomarker has some reproducibility, and practically it needs to have minimal invasiveness, and the cost should be relatively low. So, as I've previously mentioned, there are numerous biomarkers that exist, and several biomarkers that are specific to tobacco combustion. In these presentations on this site, we're actually only going to be discussing hair nicotine and salivary cotinine. And the reason that we've picked those two biomarkers is we feel that they're relatively easy to collect. Transportation's very easy to ship to a lab for processing. The cost is also relatively low in conducting these. But they have pros and cons, and you need to decide which one is best for you. Ultimately, the goals and aims of your project are going to determine which biomarker of exposure best suits your needs and best suits the proposed study. It's important to note here that you can see hair nicotine and salivary cotinine. They also provide different time lengths or time frames for which a person would be exposed. So for instance, you see on hair nicotine, it's a long-term dose. You're looking at an exposure that happened 1 to 3 months prior. Whereas if you're using saliva to measure secondhand smoke exposure, it's on a much shorter term, only on 1 to 2 days before sample collection. Compared to each other, salivary cotinine is actually a little bit more difficult to handle just in terms of storing and shipping to the lab. You need to actually keep it in the freezer and sent to the lab on dry ice. Whereas with hair nicotine, you don't need to keep it in any sort of special cooled environment. It can be kept at room temperature and just shipped to the lab in a standard mailing envelope. And then on the other hand, some uncertainties still exist in terms of doing the hair analysis for the nicotine. It's important to capture what the natural hair color is of the individual and whether or not they've had any hair treatment, such as a perm or any hair dye or hair coloring put onto their hair, because this could potentially affect the absorption of nicotine into the hair. But both methods are relatively accepted in the field and will provide ample evidence to support whether or not an individual or a population was exposed to secondhand smoke. So before beginning to actually collect and monitor secondhand smoke exposure at an individual level particularly, it's necessary to actually establish objectives or aims of your project. So your aims or your objectives should be specific and indicate what your study population is. If it's trying to address too broad of a population, it's likely not feasible and may not always answer your study questions. So those are some of the things that you need to think about before identifying your objectives for your study. So here we've listed the 3 generally most common objectives for monitoring secondhand smoke at an individual level. The first one, to characterize the average level of nicotine or cotinine in a specific population exposed to secondhand smoke. Second one, to identify factors related to differences in levels of secondhand smoke exposure among different populations. And thirdly, to evaluate the impact of smoking restrictions on secondhand smoke concentrations on specific populations. So these 3 objectives are relatively broad and don't specify which specific populations you would like to address. So that's something that you need to have in the back of your mind first. For example, if the goal of the project is to estimate secondhand smoke exposure among hospitality employees, which would be your specific population, you would then need to recruit employees from various hospitality venues to participate. However, it's nearly impossible to collect information or data on all hospitality workers, so a subset of this population would likely need to be selected. And so by a subset of the hospitality employee population, I mean that you would need to go in and select a smaller number that could perhaps represent the entire population of hospitality industry, just to give you an idea of what their exposure might be like. So here is an example of a field worker out in the field during a busy shift at a bar or nightclub, collecting a hair sample from a field worker in this particular study. And the hair sample that they're collecting will actually be representative of the past 1 to 3 months exposure to secondhand smoke that this particular employee had, not their exposure to secondhand smoke over their 8-hour work shift in this particular bar would be. So as you'll see through the rest of the presentation, it's important to actually gather other information beyond just the hair sample so that you can assess where else they may be exposed to secondhand smoke. So once you have your objectives and your goals determined and you've decided which biomarker you want to go forth and use to measure or monitor secondhand smoke exposure at an individual level, there are several steps that you need to take before you can actually get into the field and start collecting your sample. Those steps include obtaining ethics approval. And ethics approval is often needed when working with and collecting personal information from a study participant, whether or not that's biological in nature. And the steps necessary to receive this type of approval depends on your organization or your country where you're submitting the application to do the study. Generally, the objectives of the ethics committee is simply to ensure and protect the rights and welfare of participants from the study procedures. Beyond determining the population that you'll be working with, it's important that you determine an appropriate sample size or the number of participants needed to produce any meaningful results and avoid making incorrect assumptions with the final data. So here too, sample size calculations are dependent on the aims or the objectives of your project. When determining the number of participants needed, issues of feasibility must be considered, including time constraints, as well as monetary and resource restrictions. So again, while collecting a large sample size may provide the assurance of addressing the aims of the project, it may not be feasible or viable. In future slides, we're going to actually go over a few points on how to actually do sampling. So now you have your sample size and you know the population that you want to work with. Now you need to actually request participation. You need to be able to secure the number of participants that you want. So whether that's through advertisements in the newspaper or if it's by working with a local doctor's office in their waiting room and soliciting people to participate in the study, you need to have a method set up on how you're going to recruit individuals into the study. So it's important then that you also have secured a location where you can collect samples and a time frame that's most convenient for people to come. And the very last thing then is to prepare sample collection kits. And again, in future slides, we're going to go over what sample collection kits actually entail. So here we see a document that we refer to as our informed consent. And as we talked about previously, you needed to obtain ethics committee approval. You also need to obtain consent from the participant before you go ahead and collect information from them, whether that's on the questionnaire or a biological sample such as hair or salivary coating in this particular instance. So this document just goes over the points of the study, the procedures that will be conducted, how long the procedure will actually last for the participant, and any risks or benefits that the subject may actually receive. Now, this may be orally presented to a future participant or subject, or in some instances, it's actually a written document and you can ask for their signature. It really is dependent on what your ethics review committee permits. So as I discussed earlier, I said we were going to give you some example sampling strategies so that you could draw in the population that you needed to collect the samples from. And here are the two most common ways of doing that. One is the random sampling and the other is non-random sampling. Generally, random sampling can include stratified random sampling or multi-stage cluster sampling, two topics that can be rather in-depth and not actually the purpose of this presentation. But as you can see here, we've given a description and the pros and cons of random sampling. So for most studies, you'll actually be using non-random sampling. For example, in a study, if you were looking to measure secondhand smoke exposure among children and parents, you could recruit these, as I mentioned earlier, in a doctor's office at the waiting room or through a daycare. You could solicit them there, asking if they'd be interested in providing a sample and a brief questionnaire. So when studying the predictors of secondhand smoke exposure or evaluating the impacts of interventions on exposure, these approaches for recruitment are recommended. The non-random sampling approaches for recruitment are recommended. Only when the goal is to estimate prevalence of secondhand smoke among a broader population would random sampling design be necessary or required. So for the continuation of this presentation, we're going to follow what we refer to as a cross-sectional survey or a non-random sampling convenience survey. And we're going to be looking at bars and nightclubs. And we'll say we're going to select 10 bars or 10 nightclubs to participate in the study. And these bars or nightclubs will be determined based solely on what the field staff feels is most popular bar, try to vary them in different socioeconomic areas and different locations within a city. And then we'll select 5 employees from each of the 10 bars to provide a biomarker sample and to answer some questions on a brief survey. So these employees would thus be non-smokers, as smokers, of course, would have a high level of nicotine or cotinine in their hair or their saliva. So here you see a list of materials that you would need when collecting a hair sample to measure secondhand smoke at the individual level. In a few moments, we're going to go over the actual process and how each of these will be used in collecting the sample. So you'll need consent forms to collect the consent of the participant unless you're actually using an oral consent, whereby you wouldn't have a written document. And an oral consent would mean that you would actually just read, essentially, the procedures and the risks or any benefits associated with the study to the subject. And instead of the subject actually signing on a line their signature, they would just verbally say to you, yes, I would agree to participate in the study, or no, I do not agree to participate in the study. So briefly, that's the difference between an oral consent and a written consent. You would also need to have questionnaires and any other data forms that you'll be using in the field to collect information on the location and the individual. You'll need gloves, alcohol wipes, hair clips, rulers, Ziploc bags, scissors, tape, and envelopes. So as we just mentioned, you need to obtain the consent of the individual in participating in the study. And then beyond that, you're ready to go ahead and collect the sample and other information. So you'd begin with collecting information on the hair color and any recent hair treatment that the subject might have had done to their hair. You'll put on the gloves not only to protect yourself, but also as a way of showing the research participant that you're trying to be as hygienic as possible during this entire procedure. You'll take a ruler then that you have, and you'll actually measure the subject's hair length. And the hair needs to be at least 3 centimeters in length from the scalp end to the tip. If it's less than 3 centimeters, the subject will not be able to participate in providing a sample collection, as the hair will not be long enough to actually analyze in the lab and would not provide viable results. So once the subject's hair has been measured and you've determined that it's at least 3 centimeters in length, then you'll go ahead and you'll take the scissors and wipe them down with an alcohol wipe in an effort to sanitize them, presuming that you won't have a set of scissors for each individual participating in the study, which is not a feasible option for most people. Next, you're going to actually need to locate where you're going to be collecting the sample. So we say locate the vertex posterior of the subject's head, which is rather complicated in terminology, but it's simple in actually doing. And what we mean is actually the upper back portion of the scalp. So what you would do is you would draw an imaginary line from the top of the participant or subject's ear towards the back of their head. And along this imaginary line, you're going to start looking for a place where it looks like the hair growth is evenly distributed. And so this should be just about in the back of the middle of the head. And you'll actually do this along the left-hand side and also along the right-hand side. So once you've found a spot on the right-hand side, let's say to begin with, you go ahead and you'll lift up a portion of the hair there and clip it with the hair clip. And you're going to go ahead and then grasp 30 to 50 strands of hair. And you can just quickly, sort of count how many hair strands you have. Pulling the hair tautly, you'll go ahead and you'll take the scissors as close to the scalp as you can get without actually cutting the subject or the individual, and you'll cut the 30 to 50 strands of hair. And you'll do that again on the left-hand side. So you'll end up with 2 samples of hair, 30 to 50 strands each. So then you'll take and tape the hair samples on a pre-labeled envelope. And if you don't have envelopes that are pre-printed, you could also tape them to an index card, ensuring that you place the part of the hair where you actually cut closest to the scalp, referred to as the scalp end. You mark that appropriately on the index card. And if you had the envelope as shown here that's pre-printed, you just go ahead and you ensure that you line up the scalp end towards the line that says scalp end and place the tape where it says adhere tape. And then the rest of the hair hangs over the envelope. If the hair is longer than the width of the envelope or the index card, you can go ahead and just cut it off at the end and discard that portion of the hair. If the sample is too short to actually adhere or to tape to the front of the envelope or the index card, you can go ahead and you put it inside the envelope or just put it inside the Ziploc bag itself. And then you'd put the envelope inside the Ziploc baggie and go ahead and seal it, ensuring that you have an ID number on the front of the sample. And we'll talk about using unique identifiers to appropriately label and mark your samples so you can identify whom they actually came from in the next slide. So in addition to actually having a hair sample, it's important to have information or background information on the individual. And if you have that on a questionnaire or a data form, you need to link the data form to the hair sample so that during analysis, the two can be linked and you can have an appropriate information to make some assumptions and to understand exactly what the individual was exposed to and to understand your overall results better. So each subject or each participant needs to have a unique identifier. This can be a series of numbers, it can be a series of numbers and letters, but it should not contain any of the subject's personal identifying information, such as a social security number or a unique identifier that each person has in your city or your country. It should not contain any part of their birth date or their initials. It should be a number or an alphanumeric set of numbers or set of codes that you've generated and are giving to each individual. And that unique identifier then would be placed on all samples, whether that's hair or salivary cotinine samples, as well as on questionnaires or data collection forms. It's important not to repeat these ID numbers. As I said, each individual needs to have a unique identification number, and you're going to need to keep a list of all of these numbers so that you can remember which numbers that you've used and which numbers still remain unused. It's often helpful to pre-print these labels on your sample collection sheets, as well as any envelopes or tubes used to collect samples. This will help minimize data errors or errors in the field in the future, and ensure that each ID number matches its mate. So if you have an ID number on a sample sheet, that the ID number then matches the sample tube or the sample envelope for the biological specimen. So once you've collected your samples and you have all of your data information, you need to store them in a smoke-free, room temperature environment before shipping them to the lab. This will just assure that there's no contamination or any problems with the samples before they arrive to the lab. And in terms of shipping to the lab, hair does not require any special shipping procedures such as shipping on ice. It can be shipped just in a standard mailing envelope. We often advise having a project coordinator or someone who can oversee that the study and the protocol for the sample collection procedures are being adhered to. So this is just one person who oversees all of this, and they would help organize subject and participant recruitment, distribute study materials to field workers. They would keep track of the locations and the codes used, such as the unique identifiers and where the samples were actually being collected at. They would ensure that data entry was done correctly, and then they would help prepare the shipment to send to the lab. Samples for hair, nicotine, and salivary cotinine will need to be sent to a sophisticated lab with the abilities to process each. Your lab may be able to handle this, but you would need to have assurance before going ahead and sending them to the lab, and that the processes and procedures have been reproduced many times over. This is something that Johns Hopkins may be able to assist in, identifying whether or not your lab is a lab that can handle this type of analysis, or we may be able to identify a lab in your region or your area that could do this laboratory analysis for you. So once data have been entered and cleaned in the database, statistical analysis can be conducted in an effort to make inferences about the research questions that are most relevant to the study goals and objectives that you've set up at the beginning. Analysis conducted using statistical software may range from descriptive to multivariate analysis, and again, depends on the objectives of the study, as well as the target audience of the findings. After data analysis, it's necessary then to disseminate the results to accomplish the goals and objectives of the study. So it's also often helpful to create a dissemination strategy during the planning and research design phase of the project, since the objectives for completing a secondhand smoke monitoring study will again influence who should receive the results and how to distribute the findings to this audience. So here at Hopkins, we can help assist in doing various types of secondhand smoke monitoring, whether that's at the individual level, whether that's air monitoring, or if it's personal exposure monitoring. We can provide training and data collection on any of these types of methods. We can help in designing a study. We can identify laboratories, as I've mentioned, that can help do the analysis of the samples. We can do data analysis in conjunction with you, and we may be able to assist in generating reports and disseminating the findings. And here's our contact information if you'd like to request additional help in conducting a study. You can write to us, you can email me, or you can just complete the technical assistance request form on this website. That concludes this presentation on collecting hair samples in an effort to measure individual exposure to secondhand smoke. I hope now you have a better idea of what it takes to go out into the field and actually collect the samples. Please don't hesitate to contact us if you have any questions in the future. Thank you.